So the next topic is free fall. So let us try to understand the meaning of free fall by performing one activity. Take a stone, throw it upwards. Imagine by taking a stone, you should throw upwards. It reaches to a certain height and comes down. So this is due to gravitational force, correct? So whenever the objects fall towards the earth under this force alone, we say that the objects are in free fall condition. Is there any change in the velocity of falling objects? While falling, there is no change in direction of motion of the object as it comes downwards. But due to Earth's attraction, there will be a change in the magnitude of the velocity. Any change in velocity involves acceleration. So whenever the object falls towards the earth, the acceleration is also involved. This acceleration is due to the earth's gravitational force. Therefore, this acceleration is called as acceleration due to gravity of the earth, and it is denoted by the letter small g. The unit of g is ms minus 2. We know that from the second law of motion, force is the product of mass and acceleration. Let the mass of the stone in this activity be m. We already learned that there is acceleration involved in falling objects due to gravitational force, and it is denoted by the letter g. So therefore, the magnitude of the gravitational force will be equal to the product of the mass and the acceleration due to gravity. So F is equal to m into g. So from the equations we can conclude that mg is equal to gmm by d square. So g is equal to gm by d square, where capital M is the mass of the earth and d is the distance between the object and the earth. So by solving, the final equation will be small g is equal to capital G capital M by r square. Okay, so the earth is not a perfect sphere. As the radius of the earth increases from the poles to the equator, the value of g becomes greater at the poles than at the equator. For most calculation, we can take g to be more or less constant on or near the earth. But for objects far from the earth, the acceleration due to gravitational force of earth is given by the formula. The formula is g is equal to gm by d square. So everyone will have a question like how to calculate this value of g. So to calculate value of g, we should put the values of capital G, capital M, capital R. That is g is equal to 6.7 into 10 to the power minus 11 nm square kg minus 2, and capital M is equal to 6 into 10 to the power 24 kg, and capital R is equal to 6.4 into 10 to the power 6 meter. On substituting all the values, we will be getting the answer as small g is equal to 9.8 meter per second square. So this is all about the topic. So the condition of free fall. So in this video we have learned the free fall. So free fall is nothing but when the object is thrown upwards or dropped downwards, the object comes only due to the gravitational force. Okay, so this is called as a free fall. Okay, this is called as free fall condition. So, and also we derived the formula of small g. Small g represents acceleration due to gravity, capital G represents universal gravitational constant, capital M represents mass of the earth, small m represents mass of the any objects. Okay, so and also the formula is g is equal to gm by d square. So these are the formulas which we have learnt in the free fall. G is equal to gm by d square, and also we learnt about what is called free fall. Okay, and also keep the formula in mind. For g is 9.8 meter per second square. G will be maximum at the poles, g will be 0 at the equator, g will be maximum at the depth also. Okay, and also you should keep in mind of the value of capital G, that is 6.67 into 10 to the power minus 11 nm square kg minus 2, and also keep the value of capital M, that is mass of the earth, as 6 into 10 to the power 24 kg and also keep in mind the radius of the earth as 6.4 into 10 to the power 6 meter. Okay, so these are the things we have to keep in mind to calculate the value of g and free fall. Okay.